right, what we're going to be doing here is doing a basic optimization problem using derivatives. So for this example, we're imagining that a pen is going to be created from a total of 900 feet of fencing and constructed to have 4 compartments as shown in this rectangular diagram. For convenience, we'll call these the lengths and going sideways the widths. So in order to create 4 compartments, it has to have actually 5 of these vertical walls, which are the lengths, and then 2 horizontal walls for the width. And so if we decide that x is going to be the length and y will be the width, what we know is that there are 5 vertical walls, and then added to the 2 horizontal walls, the widths, that has to add up to a total of 900 feet. But then what we want to do is we want to maximize the total area, and area is quite simply going to be the length times the width, or x, y. So what we need to do is we need to somehow maximize that area. But what we do know is we know that 5x plus 2y equals 900. So what we can do is we can compress this to an equation with only x's in it by solving for y and substituting. So we got 5x plus 2y equals 900, which means that if we solve for y, subtracting the 5x and dividing everything by 2, we get y is equal to 450 minus 5 halves x. And what that gives us is that the area is going to be equal to x times 450 minus 5 halves x, or in other words, the area in terms of just the x is 450 minus 450x minus 5 halves x squared. So in order to determine the maximum, we would find the derivative and set it equal to 0. So the derivative of this area in terms of x is 450 minus 5x. And if we set that equal to 0, we get x equals 90. So therefore, the length, in order to maximize the area, would be 90. However, how do we know that that's actually a maximum? Well, that's where the second derivative comes in. If we take the second derivative is simply equal to negative 5. And of course, since this is a negative number, we know that the x equal to 90 will be a maximum. So therefore, in order to answer the question, we know that the length is 90, but then what would be the width y? Well, we could substitute y equal to, right here, 5 times x 450 plus 2y equals 900. And then solving that for y, we get 2y equals 450, or y equals 225. The length and the width. So therefore, your final answer, if we indicate, giving the proper labels, these are in feet, that the length to maximize the area would be 90 feet. The width is 225 feet. And then the area, length times width, is 20,250 square feet is the proper label. And remember to label in feet and square feet.